I'm going to go ahead and
Faraci
the
has
recording.
joined the conference.
Everybody, my name is Jacques Boudreau. I'm an engineer at the Lafayette Regional Office here of CPRA's Operations Division. I want to welcome everybody, first of all, for coming out to the first of many events that we're going to be having here for CPRA's Coastal Industry Week. I can speak confidently and say that this is one of my favorite times that we have here as an organization, and we got a lot of good things we're looking forward to presenting and showcasing here. What I'm going to do is I'm going to go through a couple of housekeeping and general logistics before giving a brief icebreaker on the overall industry week to come, before kicking it over to the webinar presenter, who today, for Monday, March 18th, is Mr. Russ Joffrion of our engineering division. So first of all, you may have just heard the meeting is going to be recorded, and we're going to broadcast that.
Faraci
has left the conference.
We're going to broadcast that afterwards via CPRA listserv email. For any questions, I would like to encourage you to go ahead and put them into the chat box throughout Russ's presentation. I'll be monitoring the chat box and we can field them that way. What I'm going to do now is I'm going to go ahead and send in for everyone in attendance a way to message me via my state email account and a general email address for any general inquiries, and then some more direction on how we're going to field questions. And the only other thing I wanted to go through, like I mentioned, is I wanted to give a brief overview of the event. Y'all can see my screen, let me know. For those of y'all who were in attendance at our board meeting last week, Bryn Hawes, our Deputy Executive Director, showed some of this on behalf of Greg Grandy, who I believe is here in attendance as well. It centers around what's to come a week from today, which is actually the legislative event, Coastal Day at the Legislature. And I'm just going to hit on a couple of things that we're dealing with in particular here on the implementation side of CPRA. But we do have a business networking event coming up on Monday, March 25th at 8 a.m. It's at the LSU Center for River Studies, which is just adjacent to our Baton Rouge office. And then later on that day, we'll be hosting here our CPRA construction project forecast and industry briefing. It's going to be a combined virtual as well as in-person event over at the LaBelle Room. But if you got the link to attend this webinar here from our email blast, you should see additional info there for how to attend that event. There's some other info here that is pertaining to the Capitol, but in an effort to get things going here today, this is a QR code to attend the industry briefing virtually, as well as another QR code here to attend what will be our partner-led session of an industry briefing that'll occur on Tuesday, March 26th. And then finally, just want to go through and give a little overview of what's to come this week. As we're here today, Monday, March 18th, we're going to listen into Russ's presentation on our CPRA design guidelines, Marsh Creation Design Guidelines. Tomorrow, we've got one of our project managers, Todd Baker, who's going to give an update on the Chandelier Islands engineering and design. On Wednesday, we'll hear from Syed Khalil on sediment management for a sustainable ecosystem. On Thursday, we're going to hear from Stu Brown pertaining to coastal change during high tide flooding and historic storm events. And for those of y'all who are aware, Stu is in our plan development section and planning and research. He's kind of a go-to on all things involved in the coastal master plan. And then finally, on Friday of this week, Friday, March 22nd, one of our former project managers and also someone that works on our plan development section, Katie Freer, is going to be leading a presentation on avian habitat restoration, along with some of our partners at the Department of Wildlife and Fisheries, as well as someone from the Water Institute. With that, Russ, I'm going to have you go ahead and share your slides, and I want to say thanks again for everybody in attendance, and I'll look for any questions. Really appreciate it.
All right, can you guys see that?
I can see it, Russ. It's in the presenter view screen.
Okay, is that good? Yeah.
I think it'll work. Then there is a way to show the presentation view too.
Yeah, how do I do that? Let's see.
Little icon down on the bottom right, if I'm not mistaken.
I don't see anything. All it's got is stop sharing, hide, nothing. Let's see. Oh, what? Nope. Presenter view, is that it? Nope.
Yeah, I think we can probably just roll like this, Russ, but
Shoot.
I'm seeing your content here.
Okay, so I'll get started. Introduce myself real quick. My name's Russ Joffrion. I'm one of the managers at CPRA Engineering Division. Some of you guys know me, some don't. Been around for a while. Actually, have over 30 years with state civil service. I did about 10 years doing bridge construction and foundation design for about 10 years, and then came here in the early 2000s and have been having lots of fun learning marsh creation. So today we're just going to go through a little bit of background on the marsh creation design guidelines, how we got there, some improvements on the design side for design guidance, and then a few things on construction as well, because these are tightly linked together. And then we'll talk through a summary of those things, and then a few challenges, and then open it up for discussion. So get into the background. So these were put together in 2017, took about a year. And we decided that it was pretty important with the upcoming NERDA funded projects and the onslaught of design and construction projects, primarily marsh creation, that we developed some type of guidance document, and we did. And that was approved by the CPRA board in 2017. And what it does, it at least provides a consistent standard of practice for this type of project. It's available on the website, on CPRA's website, under design standards. So, why we start talking about these things. Coastal Master Plan has pretty much the equivalent structural, which is flood protection, equivalent to marsh creation projects as well. So when you look at this bar graph this way, it kind of raises the flag that there's lots of guidance on structural protection and flood protection projects way back when. There wasn't a whole lot on these types of projects for what we were trying to do. So the master plan gives you guidance. I think there's 16 billion, if can't see it real well, of proposed marsh creation projects, and that's the state line within our coastal zone. Some of these areas we've been working on for quite a while. I know myself, I've been working in Barrett area for probably over a decade. So it's really neat to see the fruits of your labors on the actual landscape. So this is kind of the guidance of what sparked the need for some type of document to move forward for designing these projects. So just real quick, they're not extremely complicated on what the project components. There's basically three major components: your marsh creation area, your borrow area in blue, and then your dredge pipeline corridor. These are the three components
Russ,
of any. Yeah.
Jacques here. Just sorry to jump
Yep.
in.
Now go ahead.
I saw a chat from Ben Hartman saying that the slide deck is not advancing, and if you are trying to show some of your slides, it is in fact still showing the top screen, or excuse me, the beginning slide.
What the heck? Let's see.
Russ, press the F5 key.
F5. I'm seeing let me stop sharing and start again, Jock. Sorry guys. I see where I'm at.
Yeah, I think there's a way to right click down there on that presentation. It's a little icon that says show slide deck as a presentation. And if you right click, it'll give you some options. I want to say that's how I've done it in the past.
let's see, slide. Oh, okay. Hold on. Y'all bear with me for 1 second. Jack, can you see this?
I'm seeing just my own view since you've stopped sharing.
Hold on. One second. Let's try this one more time. I was having computer issues yesterday. Okay, can you see what do you see, Jacques, right there?
I see your presenter view,
Okay.
which I guess will work, but it would be nice to get it in full presentation view.
Okay, so I'm gonna hit slideshow. Do you see that or you don't
Yeah.
see that?
Yeah, like somebody else was saying too, F5 is the keyboard command for that.
Okay.
I see the same thing right now though.
Do you see you see the slideshow?
I see the what I'll call the presenter view,
Okay.
not the full slideshow.
Show presenter view. I don't know what it's doing, man.
Switching. That's your computer screen, not the PowerPoint. Go back to the Zoom. Play
Okay.
the same place you were on the share,
Uh-huh.
or do new share. Yep. And just do entire screen.
Okay, hold on. All right.
So share that. Now go to PowerPoint and do start the show.
Okay, now can you see that?
Yes, that's good, Russ. We got it.
Yep, good.
Okay, if I move it, do y'all see that?
Good to go. Thanks.
Okay. All right, thanks. Appreciate it. I had technical people up in here helping me out. Thank you, Travis. Okay, so the Marsh creation components, I talked about that previously, that you got your three major components. Nothing, flashy here. So the Marsh creation project, this is just a few slides just showing generally how this stuff goes down. So it's primarily constructed, via hydraulic dredging sediment, pretty long distance. That material is spread out within a marsh creation area. And then years later, you typically 1 to 3 years, we get a platform that has jump started to help the marsh platform and the ecological side of that system start to take root and take over. So that's typically what it looks like. I wanted to run through some of the equipment because all these things are related to help implement these types of projects, and they're all marine-based equipment. So this is a view of a hydraulic dredge. This is Mississippi River dredging sand. It's 30-inch dredge, capable of dredging pretty deep, 70, 80, 90 feet. Dredge pipeline could be made of different components. Some of the parts are floating rubber hoses. Primarily steel is what's used on the Mississippi River projects due to the sand. These will come in segments that are pre-welded and then flanged together. So logistically, these larger projects are pretty challenging, especially on the river, because you have navigational safety requirements that you also need to abide by. So, but the components are the same, whether it's a river project or an inland project. You have the hydraulic dredge, you got the dredge pipe, and then you have to build the containment to hold this sediment. And this is typically accomplished by a tracked marsh buggy or a shallow draft barge mounted clamshell of some sort. What's interesting is over time, the contractors have helped to develop some equipment that's more readily available to go in some of these shallow water areas, typically where containment needs to be built without a tremendous amount of drafting requirements. So that actually is a plus. You end up with a better containment dike design template if you can take bigger chunks at a time. So I'm going to keep moving. Design guidance improvements. I thought it was important to show this slide because gives you just a snapshot of the general components of what's going on. I think Syed will be talking in the future here on subsidence, and what's going into that, the effort that CPRA has done to try to develop those parameters. And what we tend to focus on the engineering side is the volume and the elevation and the hydrology, because these things affect the initial impact of the performance of that Marsh platform. So just to get everybody, pointed in the right direction, what we're trying to do on the technical side is to jumpstart that system, so then the plant processes and the different hydrology systems and the sedimentation process can take over. So I'll move forward. In the guidelines that we have currently, this is typically how it's laid out. The beginning has general guidance on each one of these categories, and it's set up with the appendices getting more specific guidance on a particular item, like surveys is Appendix A, geotechnical is Appendix B, and on sort like that. So just for the sake of time today, I'm going to focus on three areas: the survey and geotechnical data acquisition, your marsh creation area design, and construction. These three things, I would say, impact the performance of this type of project more than the others. So we'll focus on these. So what are some of the improvements? Putting this PowerPoint together, I had to think back through, our perspective of what we were trying to do. And I would consider what we've done so far a pretty good success as a jump start of a guidance document. If it's not broke, don't fix it. But there are always some things you can improve on, and that should be in the back of everyone's mind. So I'll focus on these components only. And the one in blue, where we're talking about MCA, Marsh Creation Area Sensitivity Analysis, something new that we're probably going to add. So we'll get into data acquisition. We'll go through Marsh Creation Area Design, and then a little bit on borrow area evaluation and construction. The big highlight, I think, that we've learned is trying to identify existing oil and gas infrastructure that's existing within the landscape. I think one of my colleagues here presented on this last year, the year before, and just the challenges associated with that. And it cannot be reiterated enough. We find ourselves building these projects in more challenging areas, and that being said, within our working coast, there's existing pipelines, flow lines, active, abandoned wellheads. All these things we need to work around. So how do we do that? Well, these are the main, I would say, cast of characters that are responsible for these things: the pipeline owner, the contractor, CPRA, engineer of record, and the PLS. So each one of these people and organizations have, I would say, skin in the game with trying to identify these existing infrastructure. So what is the standard of practice? I kind of hint at it. So way back when we were putting these guidelines together, subsurface utility engineering was really just coming out. It's a whole different subset of technical engineering that needs to happen on projects. It's gotten so bad on public works projects that this is now included as part of the engineering and design, especially DOT projects. So what they did, ASCE got together and said, look, here's some general guidance on how you delineate, how you interpret, and how you identify existing subsurface information. So we use this as a jump start and say, okay, let's see if we can try to use this on our projects, and will it work? It's been pretty successful. Since 2017, we've continued to use it during the design phase, and it does a couple of things. It definitely promotes safety during construction operations, and it, more importantly, it provides a consistent standard of practice for the PLS on trying to identify and locate this information within our landscape. It also provides a consistent deliverable format for anyone involved with this,
Has joined the conference.
anyone involved with trying to interpret this information. And I'm going to kind of lead to that here in a second. So just a snapshot, we typically do bathymetric, topographic, and magnetometer surveys. So this is strictly pertaining just to magnetometer survey data. So if I'm the engineer of record on the project, what are some things that I need to know? I need to know the location of that operator, the minimum at least in X and Y, and where I'm going to do work or where I think the contractor is going to cross. I need to know a little bit more. So I would need to know depth of cover, or Z. I need to know who the operator is. Is the pipeline active? Is it abandoned? Is it still in place and just not operating? What's in it? Sometimes they will sell pipelines and put different products in it. And how big is it? The last one is pretty important, because what we tend to learn over time is these smaller diameter pipelines are actually flow lines. And that's typically where we have issues. The larger pipelines are probably better maintained and you can identify them easier. So why is this even important? So this is an example on a project we designed in-house where we had two pipelines, one between two existing marsh creation areas we were trying to create, and another abandoned flow line that that was going right through our marsh creation area. So how do we tackle this in design? There were several rounds of surveys that took place to try to identify what was there, to locate them, and then try to find potential issues. So I don't know if you can see my mouse or not, but where it says TOP elevation minus 7.8, this colored portion of this pipeline, the reason why it's different is because we've learned during design that that area was exposed. The top of the pipe was exposed. So then you say, well, you need to get in touch with the pipeline operator and need to tell them to cover it up. That would be great if it was in state water bottoms, but it wasn't. So it's on private property. On private property, they don't really have to do it. So unless they think it's an extreme danger, right? So that was one issue we had to deal with. The other one was the abandoned line was cutting right through where we had to construct a containment dike and place fill. So we were extremely lucky on both of these pipelines that we could contact the operator, even the abandoned line, and they were extremely they were very helpful and cooperative during construction to move forward and to be notified and coordinate so that no injuries and happen on the project. This is the same project, just a snapshot of one of the equipment access corridors that we were investigating to try to get equipment to the project area. And each one of those circles is either an abandoned or an identified wellhead. And there are more flow lines in here than I've ever seen them since I've been doing this work. So we didn't even show all of them because it's just for clarity. So what we did was, so how do you move forward with identifying that information on a plan set? You delineate the ones that you feel confident based on the information that you have obtained, and that's delineated on the plans for the construction portion. Now, what we do during construction is go back and do another survey to help verify what we've done as well. And then that information is conveyed together with the PLS, the engineer record, and the contractor before any work is done. So that I need to reiterate that because typically it's, the buck is passed. Well, just, let the contractor go out there and do something. No, that it really doesn't make it safe for anyone. What we need to do is work together to ensure that the work that we're proposing and the work that he wants to do is as safe as we can possibly get it. So, and another example is this is Spanish Pass project designed by Baird, and same example. So these guys had it pretty rough as well, trying to navigate through design and construction with a lot of existing flow lines and some identified and some not identified pipelines. So point is, this is a real deal. It's very real, and it is a tremendous effort to try to locate and to identify existing infrastructure. The good news is we do have a process to try to help and do that, and it has helped. So just y'all hang with me on pipelines. I'm almost done. It's even got to the point to where we said, okay, we really need to pick up our game and explain to the contractor and subcontractors what level of effort's been done. This is where ASC, the 3802 comes in really helpful because it defines a quality level of work that has been done by the PLS and the engineer record, and that's delineated on the plan. So this has really helped. I know I've discussed this with several engineers, not just here, to make sure that we're doing due diligence on these projects. Okay, we're going to move away from pipelines and we're going to get to geotech standards. And you guys hang with me. I'm about halfway done. So if you are familiar with the Marsh creation guidelines and the geotechnical standards, one thing you may or may not have caught is that the geotechnical standards are not just for marsh creation projects, they're for coastal restoration projects as well. So some of the same requirements that you need for marsh, there's also requirements in there for Barrier Island projects, shoreline protection projects. So it's a one-stop shop for all your geotechnical needs. So let's get into that. Why do we even need geotechnical guidance? Well, just look at this picture. So you dredge your material 4, 5, 6 miles away. It's in a state that was probably put there by the deltaic process. Now you're going to disrupt it. You're going to put it in a pipe, basically emulsify it, and turn it into 80% water, and then let it come out of a pipeline into a marsh creation area that looks like Borden chocolate milk. And by the way, I want you to figure out how much that's going to consolidate. So let's get into it, all right? So we did make some headway on the subsurface requirements. So, how many borings, how many CPTs do I need? How do I lay these out? Where do they need to be taken? In 2017, we had the previous version of this table. It was updated in 2019 based on some feedback and just field observations and, scaling things back a little bit to try to be a little bit more realistic of what you really need. And that's where this revision came from. We optimized the locations and the depths to not go crazy, basically. Let's do just what we need to do to give enough information so that the engineer is confident on what he's trying to accomplish. So that's actually, I think, worked out pretty well. We've had consistent deliverables, pretty good feedback on that. Here's an example. I think this is BS 38, where we have borings we're taking in Grand Lake, and we have borings that we're taking on the marsh creation areas. You can see the green outlines are the previous proposed containment dike alignments. So, this was laid out and discussed with the engineer of record and the geotechnical engineer to say, okay, what can we do? Where are we going to take these? What makes sense? And it's a combination of borings and cone penetrometer tests. So CPTs are usually taken along the dike, and borings are every now and then. Definitely borings within the borrow area, and I'll get to that. So if I'm gathering this data on a geotechnical investigation, this is just an example of what that soil profile might look like. So on each end are 2 borings that we're taking, and in the middle are several CPTs that we're taking. And both are really good. You got some guys that just want to use borings, and you got some guys that just like CPTs. So with the type of work that we're doing, I think the combination that we have works really well. The CPT advantage is it can give you more detailed analysis on identifying these smaller layers of material. Like you might have intermediate mixed sand layers in there. Borings, you may or may not pick them up. And what that does, it could help you when you're estimating consolidation. All right, so the whole gist of this, was talking earlier about that soft material coming out that pipe. So 80% water. So this is kind of a schematic of really what's happening to the slurry. So what's happening is it's being dredged from a borrow area with a void ratio about 2.5. And then it's being placed on the right side, would be a construction scenario, in a very liquid state. And then over time, 20 years typically, the water is squeezed out due to its own weight and consolidation of itself to what we get on the left side. So basically, in construction, my void ratio is doubling, is what's happening. So basically, this material is bulking 2 to 3 times it in its natural state. And then we engineers have to estimate what it's going to look like at that 20-year mark. And there's a way to do that using some software called PSDDF, where it looks at the long-term self-weight consolidation. And we have testing requirements on how to do that within the guidelines. I'm not going to get into that because we'll be here for a while. But basically, there's a way to estimate that TY20 platform elevation. But one thing I want to warn you about is it's not like a typical soil or embankment type earthworks project, in that I can't specifically use my elevation during construction for acceptance. And I'll show you why. So we'll hit that way. So here's how, what we typically do, where one of our geotechnical consultants, I think this was done by APS, estimated several different slurry heights to determine the long-term performance of that marsh platform. And that's these dotted lines. And what the blue swath is showing you is that this is the zone where we're trying to estimate over time to where this Marsh platform could be performing at where it needs to be. In other words, there's different types of zone requirements for inundation, depending on what type of marsh that you're in. So that'll either get, usually from here, it'll probably get smaller. So the gist is this: long term, I'm trying to estimate now a long-term performance of the platform while incorporating sea level rise and my water hydrology requirements over time. I guess that's the best way to describe that. But you can see they have several different heights they ran. They ran 3.23, 3.73, and 2.74. And you get different curves. These curves are used for benefits for the project that then go back to the rankings of the project when they're picked. So one thing we have changed is estimating the actual volume needed for each creation area. We've changed this methodology, and what we've done is we're going back to the knowns. In other words, we used the TY20 marsh elevation to compute the actual volume that we need. And that typically ranges from 1 to 1.3. And then what you need to do is use the void ratio of your borrow area to that void ratio that you estimate TY20. And that's where you get your cut to fill ratio. So honestly, it's anywhere from 0.8 to 1 is typically what we see. That's a big change that we've done, and we've actually based that on measured data. So that's helped optimize the work and volume that needs to be done to achieve the benefits of the project and reduce some costs. So that's been a really big jump. Let's see. So we go to the next thing. I'm going to switch real quick to containment dikes. So in order to hold this fill material, we have to build in situ containment dikes, typically done with a marsh hoe and side casted. One of the upgrades we're talking about doing is to look at a different case under the slope stability analysis. So this is in here right now. This is table B5. And what we're thinking about doing is adding a construction case where what happens if the contractor overbills? Let's just add the case now in design to see how does that really impact your factor safety, so that you know that before you go to construction. And you could also look at another case if he overdigs and the weights increase, how does that impact? So these are some things that we're gonna probably upgrade on this table. Another one I would like to tell the designers who are listening, this was really meant to be 10 foot below existing grade. So this -10, everybody uses this as the max. It's not necessarily the case. If I'm in 2 or 3 foot of water, I want to go down to -13. I really want to go down as deep as I can. That's stable. So this will probably be updated as well. Okay, so why? Why is this important? And what are we trying to do? Well, it provides you some guidance for the constructability of the containment dike. It enables the engineer to anticipate ECD problems prior to construction. That's been one of our really things we've been working on here the past 2 years. It could be part of a quality assurance program, and it helps provide consistency. So here's a couple of examples where they ran 2 different cases. They ran a constructability case. Here, the black thing is the pontoon or the distributed load based on the your marsh buggy. So this is during construction. And then this is another one post-construction to see what factors of safety. Is my dike still stable? And then just here's an example of the result. So the thing that I've seen that's really a plus is our geotechnical engineering reports and the data collection reports have really stepped up their game. It's some really good data. It's presented very well. It's an easy read. These deliverable formats has really helped, I think, move things along a lot easier. And especially if you want to go back and look at some information. Okay, so earlier I was talking about your marsh fill. Like, why can't we base our acceptance of the marsh on the elevation? I'm going to show you why you can't. So, well, I'm not saying you can't, but I'm going to tell you it's extremely difficult. So if you do this type of sensitivity analysis, it's a what if. What if the contractor does this? What's the outcome? This is a really good game we play internally, and I think some of these we're going to include in the next update on the marsh creation guidelines. It also provides you some insight of maybe what areas you need to focus on during construction. So here's a what if. What if I have a marsh creation area, my production rate is varied. So we're pretty good, guys, but we're not that good. Like, we have to deal with varying dredging production rates because so does the dredger. So honestly, the dredger really doesn't know what his production rate is going to be until he hooks up every hose, every pump, every bend, everything in his whole system. Who's operating the dredge, the conditions, they really have no idea. So during design, what do? We look at a range of different production rates based on past information. And, well, how would that impact my slurry height? So volume being the same, I have one dredge and his production rate changes. How does that impact my slurry height? It could impact it by almost half a foot. So if I'm looking at the slurry for acceptance, how do I know which one's correct? I don't. So I'm going to get to that. That's just if you do a sensitivity analysis on dredging production rate. So the gist is the faster he puts it in there, the higher my slurry. The lower he takes his time, the lower my slurry. Here's another what if. What if within the same borrow area, I get a material that's varying? The top 5 feet has a liquid limit of 80, and the next 10 feet has a liquid limit of 65. What does that do? It extremely messes with your time for that material to consolidate. The more liquid the material, the longer it takes for the water to get squeezed out. Now my time is impacted quite a bit, a lot. My slurry height could be impacted a half a foot, and my time from where that material is really a solid platform is a lot different. So that's a couple of what ifs that we're doing. Another thing that we've been working on, and I'll give Adam Linson some credit on this because I stole it from his project, but and I think Stephen Cook led the charge. So the other thing that impacts dredging is the material that you're dredging. So we started this probably 2 or 3 years ago, maybe a little longer, where we take a much closer look at the type of material that we're dredging and the moisture content of that material. The gist of it is liquidity index. If If you're above 1, that means that the material is behaving more like a liquid. It's easily dredgeable. The lower you get away from there, that means less moisture that's in that material and could potentially have some dredgeability problems. So this is just an example of things that we were looking at to try to anticipate some issues before we get to construction. Okay, speaking of construction, is everybody hanging with me? I hope y'all doing all right. I got about maybe 5 minutes left. So construction guidance, it's important, guys, that if you're dealing with any type of geotechnical work, that the construction component is always linked to the design component and vice versa. So we've been working pretty hard to try to make that connection. So like I said, containment dikes, they're never built in one lift. It's pretty much impossible with the conditions that we work in. You probably have a minimum of 3 lifts with a shaping lift. And then if you're lucky, you end up with what you got on the right side, which is really nice. Once again, Marsh Creation Construction. It's just to kind of reiterate, here's the things that we're trying to do. So in construction, there are some things you can do. If you document your project pretty well and you have some good construction oversight, you have records that can help inform you of future designs. And here's an example on Lake DeCad project. There's an excellent record of the dredging production rate over time. And this is extremely valuable when you're trying to estimate the duration for the volume that you need to dredge, because it pretty much controls everything. As I was showing you, if you're off on that production rate, you're going to impact that slurry height. So this is a good example that shows he had a really good rate right at the beginning and probably moved the dredge, and then very consistent from that point forward. It's just an example. The other thing that we're doing in construction is trying to gather data during construction. This is more geotech side. It's normal geotech practice, piezometers, pressure cells. Any one of these types of things is normal earthworks geotechnical practice, and we're applying this to the Marsh side to get a better understanding of what's going on and to help monitor that information and potentially use another instrument to measure slurry density. So we borrowed that from the drill shaft industry. So some of the things that some of us have learned in the past, we're trying to use those now to observe project during construction to just get a better project. And then ultimately, this is where we want to try to end up, is some kind of construction quality assurance plan. This is just an example of, something that potentially could happen. So why does this benefit you? It ensures that you're getting the volume that you need as per the plans and the design. And then you get more consistent construction protocol if the same process is followed over regardless of contractor. So summary and challenges, maybe 3 more minutes if y'all just hang with me. Summary. So, the Marsh creation design criteria, your survey and data acquisition and your subsurface investigation, I think we're doing okay there. We can look under the hood again to see if we can optimize even more, but I think we're pretty close. Same thing with ECD design and your marsh fill elevation. The sensitivity analysis is something that's new, that ties all this together. Your bar area evaluation, that's definitely something that needs to include the few things that I talked about. And then it was always our intent that the construction component be built up to even more than what we have now to tie all this together. Oh, okay, say some challenges. These are just a few. Man, unknown pipeline operators is getting to be really challenging. Like I said, the known pipeline operators, the big guys, those are you can find that information. You know where they are. The flow lines are extremely difficult. And you know, it is what it is. Somebody handed us this bag and we're left dealing with it, guys. And it is not easy. I'm not saying it's right, but it is what it is. But regardless of what's there, it's our duty to try to move forward and to reduce the risks on the project and make sure that your project is safe. The other one is changing landscape. So this has happened on several projects. It's normally it's a pretty normal thing, but it seems here lately that it's just gotten to be a little bit more difficult with things changing pretty quickly. Even inland, there's quite a difference between our design survey and pre-construction survey, and that takes time to realign containment dikes. Your volumes change, so kind of on the whim, you're readjusted and optimized, and that's it's a challenge, but it's something that we do. The other one, I think Rudy talked about this one, is construction costs have been increasing since 2022. I mean, there's all kind of things that have been linked to this increase. Fuel prices, a lot of labor shortages. That's been a real deal from some of our contractors, and including equipment parts. Like one project somebody was working on, the pile driving hammer broke, and the only way to get the part is overseas, and it takes 3-4 months. I mean, you know, things like that. That seems to be a more common problem than it has been in the last 10 years. So it's something to think about. So what are we doing to combat these challenges that we faced? I mean, it's kind of how engineers think, right? You got a problem, you identify the problem. So I think we're going to continue to use the subsurface utility engineering guidance document to delineate pipeline operators. I think it works well. And I have always done, but even more so, the value engineering efforts are that are conducted post-construction. I think this is a great way to minimize constructability issues and optimize your features the best that you can based on the data that you have. Your cost, you know, the more we bid projects, the better are we, you know, more reliable we are on trying to help estimate what those costs are. But it's just like any cost, it's an estimate. Let's see, updating the guidelines. I think it's a real deal. You know, we base it on applied experience, real data, to then provide some guidance for construction optimization with the intent to implement that project. And I think the last one, quality assurance protocol for these types of projects, it should help provide some inspection consistency and hopefully reduce construction delays. That's the intent. And why utilize standards? I mean, it's pretty self-explanatory. So every project has risks. You want to reduce those risks for the owner, the contractor, and the engineer of record, because we're all in it no matter what. You need some type of minimum design standard consistent with what I would say would be sound engineering practices to construct these projects. You need consistent protocol. That's a big one. right or wrong. If you're pointed in the right direction, you're consistent, and that gives you some leverage to then reevaluate where you are, and if you need to optimize that process, you can. I think we heard due diligence quite a bit here lately. There you go. So if you have standards of practice, then you're doing due diligence for any project. And then the last thing, it's always the right thing to do. So I think I heard this recently here that, always do the right thing, even if nobody's looking. I strongly stand by that, especially if you're an engineer. So that's really all I had, Jock. After this slide is reiteration, I think, of what you talked about earlier. So
Yeah, appreciate it, Russ. Good job. We did have a question come through from Ranjit. I responded to him, but I did want to allow you to have a chance to weigh in. His question, I'm just going to repeat it here. It says, Russ, any thoughts on how sea level rise will be accommodated in these guidelines going forward? And Russ, just heads up, I pointed him back to the section where you brought up the settlement curve.
yeah,
And I really liked what you had to say there. I don't know if you wanted to go back, but I'll let you kind of take it from here.
yeah. Let's see. So thanks, Ranjit. Appreciate you chiming in and listening to my rhetoric. So yeah, so the Marsh creation design area on consolidation. So sea level rise, we actually rely on our planning guys to and division to give us guidance on the estimated sea level rise requirements. I think they just updated that here recently. I don't know if we've incorporated them yet on a new project, but that's where we get our criteria from, as well as for subsidence. So what we try to do is keep the water with the water and the land with the land. So we'll include the sea level rise with our all of our water level data evaluation, and then we will keep subsidence with our consolidation. We'll add that into our foundation settlement. So I don't know if that answered your question.
Yeah, thanks, Russ. I'll just elaborate and say it's really our way of trying to account for relative sea level rise.
That's right.
Here's another question here from, okay, got a response from Ranjit, from Mike Juno, who works for Premier
Mike.
Geotech and Testing. Russ, do you plan to leave the containment levies in place after the marsh fill is consolidated, or do you plan to cut the containment levees to allow natural water flow to occur? It sounds like he's kind of getting at our containment dike degradation gapping that we do, but yeah, I'll let you handle it, Russ.
Yeah, good question. As you know, appreciate it. It depends on the project. So primarily what we found, especially if you're exposed somewhat, and pretty much all these places are now, but if you're exposed, we'd like to leave as much of the dike up as we can. It depends. If you're butted up against existing marsh, then we may degrade the whole thing. But if you're exposed or like adjacent to an existing open water area, we might try to leave it up a little bit longer and gap it. So regardless, at the end of the construction project, typically what happens is we meet with the federal sponsor and we will go out, and over time the actual low water areas you'll be able to see where things are naturally low and where it wants to gap, and we'll kind of anticipate that and work with the contractor and make that happen.
Yeah, Russ, good job. And I do want to make a mention to say our regional offices out of Lafayette, for instance, where I work, we do take care of post-construction, we call O&M, operations and maintenance. It is not out of the realm of possibility that you see an O&M event occur where we're gapping containment dikes. So we definitely take that into account there, Mike.
Well, good questions, guys. I'm going to go through the end of just the upcoming. I'm going to reiterate what Jock talked about earlier. So tomorrow is Chandler Islands. Todd Baker is going to be presenting that. Wednesday is sediment management. It's going to be presented by Syed Khalil. Thursday, Stuart Brown's going to be talking about coastal change using the high tide, flood, and historic storms. And then Friday, it's Bird Day. I'll just leave it like that. It's just Bird Day. Katie Freer is going to take it home, talking about the avian habitat. And that's really all I had. I don't even know if this is still right, Jock, but that's what's on here. And then I didn't have my email address on there, but if anyone does need to get in contact with me, you could find me. My email is russ.joffrion@la.gov.
Appreciate it, Russ, and thanks again, everybody. Just for reference, for tomorrow's Chandelier Island session, it'll be at the same time. It's actually going to use the same Zoom link, but hope to see everyone there tomorrow, and for all the other events that are going to be taking place henceforth. Y'all have a good one, and thanks again for attending.
All right.
Thank you, Jock. Appreciate it. Thanks, guys.
See you, Russ. All right.
Bye, y'all.